Day 18 buffers. Number 55, the blood problem. The blood problem probably is one of my favorite Chem 2 problems. We're going to do A, and then the next video will be B, and I'll leave you do C. Hint, hint, hint. All right. A, blood is buffered by the carbonic acid and the bicarbonate ion. We have, so normal blood plasma is 0.024 molar bicarbonate and 0.0012 molar carbonic acid. It gives you pKa1 at body temperature is 6.1. A, what is the pH of blood plasma? All right, well, this would be a buffer. How do I know it's a buffer? It tells me it's a buffer. All right, buffer. So, pH for A, pH equals pKa plus the log of the concentration of base over the concentration of acid. Which one's which? Well, pKa, Ka for carbonic acid, so this is the acid. That means bicarbonate would be the base. All right, so the pH equals pKa is 6.1 plus the log concentration of acid and concentration of base. Base is 0.024 molar, acid 0.0012 molar. Right, so that gives me a pH of 7.40. So there's normal blood pH. Part B. Part B. Now, the volume of blood in a normal adult, let's say, is 5 liters. Of course, that's an estimate, right? 5 liters. What mass? There's your question. What mass of HCl can be neutralized by this buffering system in blood before the pH falls below 7, which will result in death? We don't want that to happen. So, I have 5.0 liters is my volume. All right. Okay, we're looking for how many grams HCl, and we're going to get that from the concentration at H3O+, right? All right, we're going to get that from the pH. Now, we need to know, all right, because we want grams, we can't just use concentration because I need grams of HCl. I'll need the concentration, right, involved in this. So what I'm going to do is take my 5 liters and use both my concentrations to figure out how many moles of each carbonic acid and bicarbonate I have. So write it down again. H2CO3 happens to be 0.0012 molar, and HCO3 minus happens to be 0.024 molar. All right, so if I have 5.0 liters, 1 liter is 0.0012 moles. That gives me 0.00660 moles. Of carbonic acid, and same thing here, 5.0 liters times, for 1 liter there is 0.024 moles, and that gives me 0.12 moles, right? Yes. All right, what's my reaction? Well, HCl, or H3O plus, right, because HCl is a strong acid, is going to react with what? All right, so the question is, HCl, or H, is a proton donor. Hydronium is a proton donor. So I need to react with the proton acceptor. Which one of these is a proton acceptor? Is it carbonic acid or is it bicarbonate? Well, which one's the base? Bicarbonate can accept a proton. All right, carbonic acid cannot accept a proton. So it's going to react with HCO3 minus. And we're going to go to H2CO3 and water. All right, so I'm going to have some amount of acid initially added to somebody's blood. And initially I have 0.12 moles of bicarbonate and 0.0060 moles of carbonic acid, and water it's not involved in the equilibrium constant. Well, we're going to assume all of my acid reacts. So at the end, or the equilibrium here, I'm going to have virtually no added hydronium. I'll have 0.12 moles of bicarbonate plus whatever we added, and I'll have minus X there. Getting ahead of myself. 0.0060 moles plus whatever we add. All right. The same Henderson-Hasselbalch equation. Why can I do that? I have a buffer still. Neither one of those is 0, right? We're assuming that it's not going to be 0. So pH equals pKa plus the log of base over acid. So the pH was 7.0. The pKa was 6.1 plus the log of base 0.12 minus X, acid 0.0060 plus X. And that's what we're looking for, this X right down here. Well, what do we do first? First step, subtract the 6.1 from both sides. 0.9 equals the log of 0.12 minus X over 0.0060 plus X. How do I get rid of the log? Well, same button on the calculator, right? 10, second log, 10 to each number. So I do 10 to both sides. Right, 10 to both sides, and we get 7.94 equals 0.12 minus X all over 0.006 plus X. We'll bring this up. All right, so I'll get 7.94 times 0.006 plus X equals 0.12 minus X. And there's my X's, put them in red. So then we do the math. 0.048 plus 7.94x equals 0.12 minus x. All right, so then I get 8.94x equals 0.072. X equals 0.0081 moles of H3O plus or HCl. That's how many moles. That is not how many grams. So if I take my, coming up here, 0.0081 moles of HCl, 1 mole of HCl is 36.46 grams of HCl. I end up with only 0.29 grams of HCl. That's all it takes.